Odontogenesis, otherwise known as tooth formation, begins during the embryonic period of prenatal development, more specifically between the 6th and 7th week. The very first stage in this development is called the initiation stage, which mainly involves the process of induction. At this point in prenatal development, embryologic tissue types begin to actively interact with each other. The outer layer of the ectoderm lining the stomodium will give rise to oral epithelium, which initially forms as two horseshoe-shaped bands of tissue. These separate bands will form the two dental arches. During the same time, ectomesenchyme derives from the neural crest cells that migrated to the area. This ectomesenchyme will form the tissue of the mature teeth and its periodontium. A basement membrane separates the oral epithelium from the ectomesenchyme. Just as the 7th week is coming to a close, the oral epithelium begins to grow deep into the ectomesenchyme to produce a new layer, the dental lamina. The dental lamina begins to form at the midline for both arches and then gradually grows posteriorly. During the initiation stage, disturbances can occur, such as anodontia, which is the absence of primary or permanent teeth, as well as a supernumerary tooth or teeth, which is when extra teeth develop in the arches. The second stage of odontogenesis begins in the 8th week. The bud stage is named for its extensive proliferation of the dental lamina into bud shapes along each arch. The oval masses grow into the surrounding ectomesenchyme. When proliferation is over, the maxillary and mandibular arch will each have 10 buds. No structural changes occur in these tissues during this stage. The dental lamina thickens where primary tooth germs aren't developing in the arches, but this will eventually disintegrate as the developing oral mucosa comes to line the oral cavity. During the bud stage, disturbances can occur, such as macro or microdontia, which are abnormally large or small teeth. The third stage of odontogenesis, the cap stage, occurs between the 9th and 10th week of prenatal development. This stage is characterized by the continuation of proliferation. The tooth bud grows unequally in different parts, which leads to a three-dimensional cap shape overlying the ectomesenchyme. The cap stage also marks different levels of cytodifferentiation, histodifferentiation, and morphodifferentiation. Morphogenesis occurs as well when a primordium of the tooth germ forms that contains the different types of tissues necessary to develop the future tooth. The three processes produce a cap shape of the enamel organ, which will eventually produce enamel on the outer surface of the crown. In the cap, the inner mass is considered dental papilla, and the remaining ectomesenchyme on the outside forms the dental sac. The three structures, the enamel organ, dental papilla, and dental sac, are considered together to be a tooth germ. Lingual to these germs is the successional dental lamina, which is the site of origin for permanent teeth. Teeth that succeed primary dentition are considered succedaneous, while teeth that don't have predecessors, the permanent molars, are considered non-succedaneous. During the cap stage, disturbances can occur, such as dens and dentae, when the enamel organ invaginates into the dental papilla, gemination, when the tooth germ tries to divide, creating a large single-rooted tooth, and fusion, which is the union of two adjacent tooth germs. The fourth stage of odontogenesis, the bell stage, occurs between the 11th and the 12th week of prenatal development. Proliferation, differentiation, and morphogenesis continue during this stage. Differentiation produces 4 types of cells within the organ. One of these, the outer enamel epithelium, is a barrier for the enamel organ. The stellate reticulum and stratum intermedium help the future production of enamel. Lastly, the inner enamel epithelium is the innermost layer of the organ that is created. At the same time, the dental papilla undergoes histodifferentiation and produces 2 tissue types: the outer cells of the dental papilla that form the dentin-secreting cells, also called odontoblasts, and the central cells of the dental papilla, which forms the primordium of the pulp. No disturbances occur in the Bell stage. The apposition stage occurs at various times throughout odontogenesis. The main processes are induction and proliferation. The hard dental tissues, enamel, dentin, and cementum, are secreted in successive layers. They are initially secreted as a partially mineralized matrix. The matrix will later undergo full mineralization to a degree that is dependent on the tissue type, enamel being the hardest, cementum the softest, and dentin in between the two. Reciprocal induction occurs between the ectodermal tissue of the enamel organ and the mesenchymal tissue of the dental papilla and dental sac. The basement membrane allows for communication between the cells. Maturation is the final stage of odontogenesis. This stage also occurs at various times throughout the development process. During this stage, the tissue types mature as they reach their full mineralization level. During the apposition and maturation stages, disturbances can occur, such as enamel dysplasia, faulty enamel development, concrescence, when enamel unionizes two root structures, and enamel pearl, which is when enamel forms in a sphere on the root. All of these stages form the primary and permanent teeth in the two dental arches.